All right, my friends, well, welcome back. In this next video, we're going to be answering one question. So one question that a lot of people have had all year is, what is 0 over 0? Or what is infinity over infinity? Well, these are clearly undefined, but if you get these as part of a limit, then we actually do have a way to approach it. So let me just give an example. Suppose I ask you to find the limit x goes to 0 of sine of x over x, and figure out what this is equal to. Well, obviously, if you were just to go ahead and plug in, you would get sine of 0 over 0, which is 0 over 0, which is undefined. But if you were to take a look at a graph of sine of x over x, which I've graphed right here, we can see very clearly that that limit is exactly 1. It's going towards a height of 1. So the question is, how can we show that algebraically? How can we prove that this limit is 1 using algebra instead of being forced to resort to a graph? And that is our topic for today, which is called Lhopitals rule. Oh, God, I don't know much French. Anyway, I don't remember if this is an accent. It doesn't matter. He's dead. So Lhopitals rule is a rule for limits. And sometimes you will also see it spelled with an S like Lhopitals, but regardless of how it's spelled, the pronunciation guide for this is Lhopitals. Famous French mathematician, really a genius dude. Okay, so here is what Lhopitals rule for limit says. If you have a limit as x approaches some value of a fraction, so f of x divided by g of x, and you take the individual limits of top and bottom, so limit x goes to a of f of x, and that's equal to 0, and the limit as x goes to a of the denominator g of x equals 0, then what Lhopitals rule says is that finding the limit as x goes to a of f of x divided by g of x is equivalent to finding the limit as x goes to a of f prime of x divided by g prime of x. Okay, and then this also works as also the same if both limits of top and bottom are plus or minus infinity. So if the limit on top and limit on bottom are both infinity, or limit on top and limit on bottom are both 0, then what you could do is finding the limit of those functions is the same as finding the limit of their derivatives. Now, a couple things to note. First off, notice that this is not the quotient rule. You are not applying quotient rule on the whole thing. You're applying the quotient rule on the top, the derivative on the top and the derivative on the bottom. Now, you might be wondering, why does this work? Basically what you're saying is, if both of these terms, if f of x and g of x are going to 0, then instead of seeing, okay, well, I'm just going to get 0 over 0. So what if I look at the rates of change? A derivative is a rate of change. So what if I look at the rate of change as f and g are approaching 0? So that's what you're basically doing here. So let's go ahead. That's Lhopitals rule, and let's apply it. So let's start with this simple example. So limit x goes to 0 of sine of x over x. Now, when you write these problems up on the AP test, what they want you to do is to write out the top and the bottom limits separately. So they do not want you to say that this is equal to 0. So not equal to 0 over 0. And the reason is because 0 over 0 is undefined. So that's why they don't want you to do that. What they want you to do when you're writing these problems up is say, okay, I'm going to write out the limit x goes to 0 of sine of x. That gives me sine of 0, which is equal to 0. I'm going to do the limit as x goes to 0 of x, which of course is just 0. So because the top and the bottom are both 0, so since both limits are 0, we can apply Lhopitals rule. Okay, and here's what Lhopitals rule says. Lhopitals rule says this whole limit is equal to the limit x goes to 0 of, and we take the derivative of the top, get cosine x. We take the derivative on the bottom, and we get 1. Now we can see, as we go ahead, we can simply just plug in, and we're going to get cosine 0 over 1, which is 1. So that's how we got the answer we expected from the graph. We use Lhopitals rule. Again, make sure you're doing this. You're showing the top and bottom limits separately. That's how you're going to earn credit on these problems. Okay, so that's Lhopitals rule. Let's look at a couple more examples. So suppose we say the limit x goes to 3 of x squared minus 5x plus 6 divided by 2x minus 6. All right, so and this is a good habit to get into anytime you're using a fraction, but do the top and the bottom limits separately. So the limit x goes to 3 of x squared minus 5x plus 6. Of course, this is super easy. This is just 9 minus 15 plus 6, that's 0. You take the limit as x goes to 3 of 2x minus 6. That's also 0, of course. So we can apply L'Hopital. So when you apply L'Hopital, this whole limit will equal limit x goes to 3. Again, not a quotient rule. I just take derivative on top, 2x minus 5. Derivative on bottom is 2. So as I plug that in, I'm going to get 6 minus 5 over 2, which is 1/2. And that's my answer. Okay. Now, one thing also, you might have noticed we could actually have done this problem using factoring, which we did all the way back at the start of the semester in August, about 14 years ago is what it feels like. So this is x minus 2 and then x minus 3 over 2 times x minus 3. So x minus 3's cancel, so we could just plug in 3, you get 1/2, and check. So it worked out that way. We got the same answer using L'Hopital's rule, which is great, right? Because now we just have a new pack in our trick, a new way to solve a problem. Okay, let's look at a few more examples. So let's take a look at the next one. Suppose we take limit x goes to 1 of x cubed minus 2x plus 1 divided by the natural log of x. Okay. So when you take a limit as x goes to 1 of the top, so you always want to do these separately, right? That's 1 minus 2 plus 1, that's 0. When you take a limit as x goes to 1 of the bottom, you get natural log of 1, which is also 0. Okay. So we're doing that basically to check and make sure you're allowed to use L'Hopital's rule. So we can use L'Hopital. So that tells us this limit will be equal to the limit x goes to 1 of 3x squared minus 2 over 1 over x. So when we do that, we get 3 times 1 minus 2 over 1, which is, I don't know, it's like 1 over 1, which is 1. Great. Okay. So that's how L'Hopital's rule is going to work. One tip I want to give you, this is a warning. Do not just blindly jump in and use L'Hopital's rule. Not blindly jump in and use L'Hopital's rule. It must be 0 over 0 on top, or it must be like infinity over infinity or something like that. Because let's say you're someone in Miss Cruzy's class, and you just look and you like blindly use L'Hopital's rule. Limit x goes to, so let's say you're trying to find this limit. X goes to 1 of like x squared over 3x plus 1. Now let's say again you're just a massive chump. So you're just like, oh, I'm just going to go ahead and use L'Hopital's, her. So I'm going to take this limit and I'm going to get 2x over 3, so I get 2/3. Well, that's great, except this answer is like blindly wrong. Like, because the top and the bottom are not 0. L'Hopital's rule only works if they're equal to 0. The correct way to do this problem, of course, is just to plug in, right? You plug in x goes 1 of x squared over 3x plus 1, you just get 1 over 3 plus 1, which is the fourth. This is the correct answer. So you can't use L'Hopital's rule if it's not 0 over 0 or infinity over infinity. So don't just blindly take derivatives. You have to go through the step of checking the top and the bottom. Okay, let's do the infinity case. So let's take a look at this. So let's suppose, for example, we have to take a limit as x goes to infinity of x divided by x squared minus 3. Now, you might have remembered the rule from this. Hey, we have a bigger power on the bottom. We know the limit's going to be 0. But we can get the same result using L'Hopital's. So on top, if you take a limit x goes to infinity of x, you just get infinity. On the bottom, if you take a limit x goes to infinity of x squared minus 3, you get infinity squared minus 3, which is, of course, still infinity. So because the top and the bottom are both infinity, we can use L'Hopital. So the derivative on top, this is going to turn out to be 1. Derivative on bottom is 2x. So then we get 1 over infinity, which is 0. So that's how this works, and that's how the infinity case works. And even if you have something like here's an example where you can't use that strategy. Say we have to take a limit x goes to infinity of e to the 2x divided by 3x plus 1. Now, because it's not a polynomial, we can't use those rules from before. So we'll look at the top. Limit x goes to infinity of e to the 2x, which is e to the infinity, which is infinity, of course. On the bottom, we take the limit x goes to infinity of 3x plus 1, which is, of course, just infinity. 3 times infinity plus 1 is still infinite. So when we apply L'Hopital, you're going to get the limit x goes to infinity of e to the 2x times 2 is the derivative there. Bottom derivative is 3. So we get 2e to the infinity over 3. So this limit is still infinite. Okay. So that's Lhopitals rule of the basics. And I'll have some more details in the next video. Thanks for watching.